Block A is initially held at rest on a horizontal table and is connected to a horizontal ideal spring that is fixed to a wall. The spring is initially at its relaxed length. Block A is connected to block B by a string passing over a pulley as shown. There is friction between block A and the table. When the block A is released, block B moves downward and block A moves to the right along the surface of the table until the system returns to rest. How do the mechanical energies of the two-block spring system and the two-block spring earth system change from when block A is held at rest to when the blocks return to rest? Here now, initially the system is in static equilibrium. That means all the forces are balanced. Here, the spring is in equilibrium position and block A is connected to the spring and then other end of the spring is connected to the rigid wall. And block A's other end is connected to block B by a string passing over a pulley. Now, when it comes to the system, block B, the forces acting are tension and gravity, and both are balanced. Am I right? All the other forces are also balanced. Now, the system is at rest. Then what happens? We are releasing the system. When we release the system, the block B goes down and block A goes towards right. Okay. Obviously, when the block B is above the ground, it has some gravitational potential energy. Am I right? And then this energy is utilized in pulling the block A. Am I right? And initially, we are talking about the block B. Block B has only gravitational potential energy initially. Block B has UG. And then no other energy as of now. We are seeing when we see as it is, we are finding that block B has some gravitational potential energy and spring and block A has no energy at all. The dissipative forces, friction is acting between the block A and the table. So the work done by the friction will be a dissipative because friction forces are non-conservative forces. So work done by the friction will not account for the total energy of the system. That also we should consider. So initially at this part, when we consider two-block spring system, the total energy is just this gravitational potential energy, nothing beyond that. When the system is released, this block is doing the work, and then that work is stored in the form of elastic potential energy. And when we consider this part here, the energy increases. Am I right? Because no energy here. And then here, the block A is pulling the spring. So the spring gets stretched. So getting the stretched means work is done on the spring. So that work should be stored in the form of elastic potential energy. Obviously, there is some energy. Even after deducting the energy, this work done by the dissipative forces, that energy also we are deducting from the total energy. Even then, there is some increase in the energy of this part. That means two block and spring system has some increase in energy. Okay. Now, when we consider the two block spring earth system, what happens? This potential energy is utilized in doing the work, no? So the energy decreases, no? And moreover, friction is also there. By the time block B reaches the ground, all it's here, let us consider this be the ground. So this is the height h. Am I right? So you have UG is equal to mgh. Am I right? So that energy is utilized in doing the work. And moreover, I told you, no, dissipative forces are there. Obviously, the energy of the two block spring at the system decreases. Okay, so in the first case, it increases in the top most case. That means two block spring system, it increases. But in the other case, it decreases. Okay, so work is done by the system. In the two block spring earth system, work is done by the system. Work is done by the system. So the energy decreases. Here, When it comes to two-block spring system, work is done on the system. Therefore, the energy increases. This is the answer for the question. Hope this helps. Thank you. Bye bye.